Hello, hello, hello. What is up? Back to another day of leak coding. Today we're doing 142 linkless cycle number 2. Um, also chewing gum again. Almost finished my pack though, so now 2 left, and then I will no longer chew gum during videos. But they're pretty good. I don't know. I think I'm like Pavloving right now. I don't know why. It just kind of locks me in when I chew gum. I can't lie. Like before I start Leetcode, I just had this slight urge of chewing gum. Ooh, I don't know, bro. I don't know. I don't know why. But it's whatever. Okay. Not much to do. Let's get started on the new Leetcode question. Cheers. Alright, linkless Psycho 2. Do I still have my highlighter? Oh, I don't have my highlight. Oh, did I copy link to highlight? No. Okay. Well, I lost my highlighter. That's unfortunate. But it's okay. I'm using a new browser just for load the game. I can't lie. And also because I have all my other accounts on my other Chrome browser. And bro, what if I open my like fucking emails or some shit? I get my email leaked. That'd be terrible. So yeah, that's why we're on Zen browser. Shout out, pretty cool bit browser. Looks pretty nice. Okay. Given how to build a linked list, return the node where the cycle begins. If there's no cycle, return no. If there is a cycle in a linked list, if there's some node in the list that can reach again continuously following the next point. Do you want to modify a linked list? Pause does not pass as a parameter. Input 320 -4 position 1. Tail connects to index 1. Do you have to output a string? What are we talking about? Oh, return null if there's no cycle. Return null where the cycle begins. So -4? No, -2, where that's where it begins. Okay. And 1 is where it begins. Okay. Okay, wow. This I actually have no clue. This is a fast slow pointer situation. Okay, I have 3204. Let's try to note this down. See, if I was a human, I would just look at the fucking arrow and see, oh, that's a cycle. But so, but like a machine cannot visually do that. So I need to like I can't think in terms of this model the diagram has given me in a sense, right? I have to think where like a machine where I see kind of a flat structure going on and just two paths. One that goes on infinitely and one that doesn't, right? Because we have we essentially don't have position, I would say. like we have no clue what the position is, and we can't effectively track it ourselves, I think. Okay. Well, from yesterday, I should not be showing my keys. I don't know why that pulled out. I don't know why I just started pulling keys out of my fucking closet. Someone's gonna 3D print my keys and I'm cooked. Thank God that's not my house keys. I don't even know what keys those are. Well, from yesterday, we know how to get to the middle of a linked list. The day before, we know how to detect if there's a cycle. Okay, first idea that popped into my head. We have a slow pointer, we have a fast pointer. And it kind of acts like a nested for loop. So we first set it at 3, and then we have a fast pointer that goes through the entire linked list. If it ends back up at 3, are all elements unique? They have to be, right? Follow-up. Can you solve it using 0, 1 constant memory? Ooh, that's a hint, which means we can solve it without. With using memory, that makes it faster, I guess. Or the intuitive solution has something to do with memory. Well, I don't know. Can I assume that elements are unique for this question? Let's ask. Grammarly. Can I assume that? I think this is a fair ask. Values is unique in the link in this question. Oh, it doesn't say. Oh, fuck, I just got a fucking hint. Oh my god. I'm stupid. You compare same memory locations. Fuck my child life. Okay. So that was a great hint. Kind of frustrated I got a hint, but it's whatever. So we have a slow pointer at the start. We have a fast pointer. we store the initial value of our fast pointer, like where it originally starts, right? Which is, let's assume, it's the same as slow pointer. Wait, what am I saying? Okay, let me draw this out. 3, 2, 4. 4 points back to 2. Are you mean the slow pointer? I do. Yes, okay. So we first set slow pointer to 3 in this 3204 scheme example, or whatever. Run a fast pointer starting at the same point as slow. Oh no, we can start it one more above slow. Okay. We start it slow dot next. And if fast pointer comes back to slow, then it's slow is the beginning of the cycle, right? If it doesn't, we do slow dot slow next. Or if fast pointer reaches the end, then we just return that. But if let's say it's not a cycle, we do slow equals slow next, and we run this again, and then we figure out at number 2, right? And this would be n squared, I think, which ultimately does kind of suck. But what can you do? This is brute force? Oh no, can you do this n of n? Well, I think we'll figure it out once we do it. Let's just, I think I'm tired of not, like, having solutions, kind of. Like, going for the most optimal one. My earlier runs, I don't think we need to necessarily. Or maybe we should, but I don't know. I think it's easier to just do the easiest one first and then iterate on top of that upon receiving feedback on how fast it was. Okay, my Vim is not working. How do I do Vim? Settings? Code editor. I want to use the restroom. I guess I gotta finish this soon though. Oh, also, don't tell answer only. Okay, whatever. Wait, how do I freaking... I guess we just don't get Vim for this one, whatever. I need to use the restroom soon, so I want to figure this out. Man, I want to use the restroom. Okay. So, slow pointer, we do slow equals head. Fast is you go to dot next. It's not even necessarily a slow or fast pointer, it's just 2 pointers. Pointer 2. Pointer 1. Okay. While pointer 2 is not equal to pointer 1. Is Python? Oh fuck. Python 3. Pointer 1 goes add, pointer 2 is equal to head dot next. While pointer 1 not equal to pointer 2. We want to do pointer 2. It's going to pointer 2 dot next is not equal to null, not equal to none, is not equal to none. Pointer 2 is equal to pointer 2 dot next. Just run this within it, right? Actually. Pointer 2 dot next. None. No. Do you return none? That's so. If that's not the case, we do pointer 2 is pointer 2 dot next. And return pointer 1. Now, how do we add? If there's a cycle, I mean, if there's no cycle, then you reach the end. And pointer 2 just dies. But in this case, how do you stop pointer 2 from going infinitely here? Because we start at 3. So I guess you must start. Pointer 1 and pointer 2 have the same space, right? Initially. Current equals head dot next. And do you even need pointer 2? I'm starting on next has the issue of routing back to next or routing back to another, like a loop, like here. So you never check 3 again. I guess you can store like a list of values. A list of memory. Like maybe let's say like. Oh, then you have to store it for like how long, right? Alright guys, you can do this. Pointer 1 goes forward and just slaps everything into an array, while pointer 2 is going forward as well. Just one ahead. Right? Okay, so pointer 1 goes forward at each one with pointer 2. Or if it goes like here. Let's say it's 3, 2, 0, 4. Pointer 1 goes forward to 2. Pointer 1 and stores 3 and 2 into like an array. Pointer 1 then goes to. Pointer 2 is the fast one, I guess. Pointer 2 then goes to 0. And then 4, and then 2. It comes back if we're storing all parts of the array, maybe in a hash table or something. Then that works, yeah. Right? Relatively easily here. You just have them both moving with one up ahead. And when the first time pointer 2 comes back and hits a pointer 1 is when, like a memory location in pointer 1 is when I found to start the cycle. It would never hit because it was never ahead before that, right? Well, it would never hit if there's no cycle because it's always ahead. The first time it hits must be the start of the cycle. Okay, but that is buttons. I think we want space of 1. Yo, what? Okay, so we have some pointer like shit going on then, I guess. I don't know, bro. This shit. Bro, I'm just such a chud, bro. No. Oh, what do I do? I genuinely don't know, bro. Chat. Maybe it's time to quit being a software engineer. You know what I'm saying? Fucking. Oh, I can become a barista, bro. That should be tough. I'll make drinks every single day. Oh. Yeah, but I can't make enough money, bro. Okay. Okay. I'm just joking. Back to work. Just joshing. Okay, there's a solution here that's alternate but better with O of 1. I know it. I know that exists somewhere. With some certainty. Because it told me so. Oh, wait. Star is crazy, though. I mean, every array or every linked list, you can technically run it n times. Run next n times. Yeah. Wait, yeah. Every slow pointer, you run the next pointer. You run a for loop. You run. You run it 1 times, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, up to n times. And if it comes back, it must come back. If it doesn't come back by nth time, then it's cooked, right? Then you know, yeah, it's not looping back, bro. And you go to the next one. But that shit's buns, bro. That's n squared now. 1, 2, 3, 4. N squared or n cubed? Once n times n 1, 1, 2, 3, 4, 5, 6, 7, 2, 1, 2, 3. 1, And yeah, that's n squared, I think. Yeah. I mean, n squared is not bad with no memory, right? Yeah, it's not bad. What about the space one? We can try to calculate the time complexity of the one where we do a hash table. It's faster, no? It's just n. If you hash it, you just keep going. And the first time it comes back, you're like, yo, that's 5. You just found it. You don't have to do it n squared times. Is runtime more important or storage? I think runtime is... I don't know what this question is trying to optimize for. Do we have... Well, if the follow-up is O of 1 constant memory, I can do an O of 1 constant memory. Like that, yeah. Just run... So we detect a cycle and be like, yo, this shit's cooked. Like, we need to collect like a cycle signature. Right, if fucking... If we do this n times thing, and we use cycle signature, that shit don't work. I'm doing stupid monkey strat. Okay, stupid monkey strat time. So the idea is, we know there's for sure not a loop if we run the head dot next 0 times, 1 time, 2 times, 3 times, up to n times, right? Because the max loop is an entire loop, and the smallest loop is like 1 loop, right? So if we go through all of that, we know there's no loops, and from that we can safely move to the next for pointer 1, being the slower one, right? And we run that all over again for pointer 2, not pointer 2, for pointer 1 dot next. Okay. Oh no, I got 20. Okay, I got 20%, guys. Gotta lock it, or else my webcam's gonna die. Okay. Well, you don't know the length of the head. Shit. The length of the linked list. How does it even work? Oh my god. I mean, you can run it infinite times. You just keep going while. Yeah, well then that sucks. At what infinite do you stop? You don't fucking know. I'm hash mapping it. I'm hashing it. I'm hashing it. I'm hashing it. A slightly bad way of doing the question is better than not finishing the question at all. We learned that from yesterday. Or maybe this is not even the right way. But not having Vim is so annoying. I'm gonna try to enable Vim again. Vim, where are you? How do I enable Vim? Leetcode. Oh, this is it. Okay. Fire. I'm stupid, man. 1 or 2 is not equal to none. Want to move? Want to do pointer 1 dot add? No map. Oh, we can do a set, right? No. Is it insert? I'm gonna need to search some shit up, I know. Oops. Hello. Mm-hmm. Wait, is Python set? Oh, it's the same thing. Oh, I'm stupid. And not pointer one in node map. Alright, because one will loop to continue while this is true, right? Pointer one is not equal to none. And if pointer one is a node map that's true, and that not sets to false, which means pointer one. When it's false, it's actually true, so that continues until it's true. Which means when pointer 1 is a node map, when pointer 2 is a node map, then we know, oh shit, we found the shit. I think this is add. Does that work? Oh my god. Oh, you just do it. Fuck. Okay. Wait, do you need like a... Do you need a key? Yeah, that fucking works. Oh, it's... what? Do I need set? No, it kind of frustrates me that I don't know Python enough. Oh, not return none. How do I do this? Oh. Fuck. Oh, this is the edge case, right? Where it's just only one. Oh. Okay. Let's see what the correct solution is. Yo, what? Okay, I don't want to look here. I'm just gonna search it up. Wow. That's kind of beautiful. Seems like a cool guy. We're using, well, he's putting on the Chinese, but this guy's cracked. Okay. Yep. We first use a fast and slow pointer to judge whether the linked list has a ring. If there's a ring, fast and slow will meet. True. If there's no ring, fast and pointer will reach and tail the linked list first, returning no. If there's a ring, we can define an answer pointer ants to the head of the linked list. The ants and the slope pointer move forward together, moving one step at a time. Until ants and the slope pointer meet, the meeting node is the entrance node. Why can't we find the entrance node of the ring? Let's assume the distance from the head node of the linked list to the entrance of the ring is x. Distance from the entrance of the ring. Oh, we start the head again. Oh my gosh. Wow. Wow, okay. Yes, that makes sense. Wow. Wow, okay. Okay, I want to look through the math again. Okay. X plus y equals k times y plus z. Wow. Well, I'm kind of confused. Because I'm literally like, my brain's not functioning. Like, I'm reading it, like, I'm not like kind of trying to I'm not internalizing, I'm not thinking about it. Because the speed of the fast pointer is twice about just the slope pointer is 2 times x. Yeah, this makes sense. Okay. So you FOIL that out. No, what am I saying? Well, how is 2 times xy equal to x plus y plus kx? The 2 is here, right? Which can deduce that x plus y equals... Okay, wait, pause. Okay. Start from the top. Okay. And your pen. Here's your pen. Pen. No, my pen. Okay. Well, I have my pen right here. Like a minute. Whatever, I'll use my colored pencil, I guess. Okay. Yes, slow pointer, x plus y, that's easy. Yes, that makes sense. Slow, x plus y. I need to like think when I'm reading. That's just like a terrible habit I have. The distance traveled by the fast pointer is x plus y plus k times y plus z. Yes, that makes sense. X plus y is equal to plus k times y plus z. That makes sense, yes. Yeah. Because the speed of the fast pointer is... Oh, this is like a proof that the slow pointer and fast pointer meet. It's 2 times xy. Because the speed of the fast pointer is twice of that of the slow pointer. It's... Okay, yes. It's 2 times x of y Ah, okay, I'm stupid, yes. As you go to x plus y plus kx, k times y plus z, yes, okay. And yes, you can deduce that, yeah, yep, x plus y will equal to k times y plus z. Yep. Okay. Wait, this proves that slope pointer and fast pointer definitely meets, no? Or how does it prove that answer definitely meets with slope pointer? Am I stupid? Yo. Control alt space. Control. I don't have space. Oh, control space. Or control alt. Option key. Okay. I just don't. I feel like I'm just not understanding. Because I'm just like, dude, I'm just so stupid, bro. Yeah. Can you re-explain the solution explanation to me? I don't get it. Yes, this makes sense. Yeah, I know, I understand this part, yes. Yes, okay. So yeah, x is equal to k, y plus z minus y. Rewrite minus y as z minus y. What? Okay. Which is z minus y, z minus y plus z. Yeah. So then x is equal to k minus y, k y plus c. Yes, minus. Yeah. Y plus z plus k plus z, yeah. So it's k minus 1, yep. Yep. Wait, what is it? Z again? Yep. Okay, wow. Okay. That makes sense. Wow, okay. That kind of makes sense, yeah. Just not intuitively, like, the math is adding up, but, like, I don't. But yeah, it, like, kind of makes sense because we define it such a way and then we, like, go from our definition, right? But I feel like I'm not, like, internalizing it, so I'm gonna read it one more time. Yes, 2xy. My brain's just not working, bro. Oh my god, I'm like getting distracted, like mid thought, and like I can't. Okay, seeing what calm down. Like, wait, I'm kind of getting lost here when I think about this intuitively, right? Because KXYZ, like, I can't imagine this. So two of these loops. Let's say you loop around it 2 times. Wait, what does it mean you're here, huh? Oh, it means you're here. Yes, okay. Yeah, that makes sense. Yes. Okay, never mind. Yes, that makes sense. Isn't this just K? Yeah, this is just labs. Yeah, K labs now. Because y plus z is just lab. Okay. Yeah, what the fuck? Oh, this just came out smart. Yeah, okay. Okay. I see. Kind of, yeah. Oh, distance z from the entrance, yes. Okay. Alright. Ah, okay. That makes sense. Okay, I think I need some time to process it, I think. Yeah, I'll come back to you another day, I think. Okay. Sounds good, looks good. Good day, good day. I don't think I'm gonna try the problem again right now. I think I need to like come back to you another day with a better solution. You know, like at the end of like a Leetcode session or something. Alright. Thanks guys. Bye.